In the last presentation, we saw the basic of the encoders and decoders, and I also told you that we have to study the 4 types of encoder, in which the first one was the priority encoder. So in this presentation, we are going to complete the priority encoder. You can see a priority encoder on the right hand side of your screen, in which there are 4 inputs: I0, I1, I2 and I3, and definitely 2 outputs, y1 and y2, because n is equal to 4, and we already know to find the value of output we have to make it equal to 2 to the power m. So solving this, m is equal to 2. Fine. Now what we have to actually do in this presentation is to find out the circuitry inside this block. Okay, and that we will do by first creating the truth table for the priority encoder, and then by using the K-map we will find out the logical expression, and the implementation part will be over you. You have to do the implementation part because it's not very tough thing to do at this stage of time. Before moving to the truth table, let us first set the priority for the inputs. I assume I0 is having the lowest priority, and I3 on the other hand is having the highest priority. So I can say that from moving from top to bottom, from I0 to I3, the priority increases. Okay, the priority increases when I come from up to down. It means I0 is having the lowest priority, then I1, then I2, then I3. What actually we have to do by setting the priority is that if I3 is 1 high, let's say, then we don't have to check for I0, I1, I2. We will just set y1 equal to 1 and y2 equal to 1, because they reflect I3. 1 1 reflect I3. Similarly, if I say I3 is 0, I2 is 0 and I1 is 1, then we don't have to actually look for I0. It is don't care for us. Whatever the value of I0, we don't have to do anything, because the priority of I0 is less than I1, and the output will be 0 1. So this is what we have to do in the priority encoder. So let's quickly move to the truth table, and once we are done with our truth table, this thing will be much clear to you. Okay, so let's start with our first case. When all the 4 inputs are 0, when all the 4 inputs are 0, then the outputs will be simply don't care. Okay, and when I3 is 0, I2 is 0, I1 is 0 and I0 is high, which means 1, then y1 is 0, y0 is 0. Very simple. Let's move to the other case. When I3 is 0, I2 is 0, I1 is 1. It's the case that we just discussed here, this one. In this, we don't have to see the value of I0. It simply don't care. If it is 0, doesn't mean anything to us, because the output will still reflect I1. If it is 1, in that case also the output will be I1. So it's don't care for us, and the output will be 0 1. Let's move to the next case, in which I3 is 0, I2 is 1. Again, I2 is having the higher priority as compared to I1 and I0. So we don't have to look for the values of I1 and I0 because of the priority of the I2, and output will be 1 0. Let's move to the another case, in which I3 is 1 and I3 is having the highest priority. So again, we don't have to look for the values of I2, I1 or I0. They will be simply don't care to us. Whatever their value, the priority is given to I3 and the output will reflect the I3. So 1 1. Okay, so this is a small truth table for the priority encoder, and I hope you have just learned what is the central idea for the priority encoder. Now the next step is to find out the logical expression for these two functions y1 and y0, and as you can see here, there are 4 inputs involved. So it is very obvious that we are going to use a 16 cell K-map, and also 2 such K-maps will be required because we are having 2 functions, y1 and y0. So let's move to it. I have already made a 16 cell K-map. So the only thing we need to do is to fill this map. Okay, and you already know how to do this. So let's do it together. Okay, so the inputs are I3, I2, I1, I0. So let's start filling it. For the first cell we are having a don't care, so cross. For the second one we are having a 0, okay, and again we are having 0 for these two cells, because in this we are having I1 as 1, and you can see that I1 is 1 for these two cells, and in that case we are having Y1 as 0. Very simple. In the next case we are having I2 as 1, okay, and when I2 is 1 and the I1 and I0 are the don't cares, we are having Y1 as 1. So let's see for what cases I2 is 1. I2 is 1 for these two entire rows. You can see this is your I2 and it is 1 for these two rows. So I will write 1 real quick without any question, because it's clearly mentioned here that output is 1 when I2 is 1. Similarly for the last case also, whatever be the value of I2 and I1, I0, if I3 is 1, Y1 is going to be 1. So we can see that for these two rows I3 is 1. So we have already put 1 here in this row. The only thing left is to put 1 in all the cells of the last row. It's a very simple K-map to do, and let's start grouping it. This is our first group, okay, and this one is our second group. Fine, let's write the minimized function. This is for Y1. So Y1 is equal to what? Let's see for this first group of ones, and let's say this is our second group of 1. So for first group of 1 we are having simply I2, because all I1, I0 is changing from 0 to 1 and I3 is also changing from 0 to 1. The only thing that's not changing is I2. So I will write I2 for the first group, or for the second group in the same way I3 is not changing, it's 1, whereas all the three I2, I1 and I0 are changing from 0 to 1. So I will write I3. So this is your first function, okay, Y1 we have just found out. Let's paste our another K-map, a 16 cell K-map, to find out the value of Y0. So let's see, for the first cell we are having a don't care, you can match from the truth table, and for the second cell we are having a 0, okay, you can see in this case it's 0, and when I1 is 1, which means for these two cells Y0 is 1, so 1 1, okay, and when I2 is 1, okay, for these two rows I2 is 1, the value of Y0 is 0, so 0 0 0, and again 0 for this row, and for the last case when I3 is 1, the output is 1. So I will put 1 1 1 1, okay, and one more important thing that you can see here in this K-map is for this I2, okay, if I see for I2 when it is 1, which means this row we have to see and this row we have to see, we have put 0, but when I see I3, which means again this row and this row, it's 1, so there is a contradiction in this row, it's 1 and 0 both, so I will take it as a don't care for us, okay, and we already know how to operate with the don't cares. If it is a don't care, I can take it as 1. So let's start making the group. I hope you are getting these things. I'm assuming that you know how to solve the K-map, okay, so this is my first group and I have combined these 4 ones, the 2 ones are still left, so let's make the second group. This is my second group, this is my first group, this is my second group, okay, so let's start writing down the minimized function. Y0 is equal to, for the first group I'm having Y3 with no doubt, we have already done in this case, and for the second group let's see what's changing and what's not. For the second group you can see that I1 is 1 and it's 1, it's not changing in this column, whereas I0 is changing from 1 to 0, so we will neglect I0 and I will write I1, and as it is a group of 4 ones we will eliminate 2 and still we are left with 2. So I1 is our first variable. Let's check for the second. out of I3 and I2. In I3 and I2, if I see for this row and for this row, I2 is not changing, it's 0 and again it's 0, whereas I3 is changing from 0 to 1. So we will neglect I3 and I will write I2 complement, because I2 is down, I2 is low, 0. So this is what we got after the simplification using the K-map for the function y0. Now these are the two functions that you got, and you can easily implement them by using the OR and AND gates, and whatever the circuit you got will go inside this priority encoder. So this is all for this presentation, a very simple topic and yet a very important topic. There is a great chances of this question being asked in your exam. So enjoy it and see you in the next presentation.